7.5 Property logarithms. So the goal of this lesson is to understand property logarithms and use them to solve log equations. It's kind of a combination of the last lesson and new stuff. So let's go over some of the log properties, some of the famous ones. First up, log to the base of a number with the same value. So let's look at that logically. So I'll give you like log base 5 of 5. What does that ask you? Remember, the way log works is like this. It's saying 5 to what power is 5? Well, 1. That's always going to be true, right? B to what power is B? 1. So anytime you see log and base the same, data is equal 1. Not happy face. 2. This is the one we talked about earlier. The one we used extensively last session. B to log base B of x. If the base and the log have the same base, and the base and the power and its exponent, which is the log, that has the same base, right? It's a mouthful. If the base has an exponent with the log of the same base, then those reduce, and you just get x. All right, so something to this effect. Again, we used this a lot last time. 3 was to log base 3 of x. These will just cancel out, and you get x. Or it could be anything, right? Log base 3 log base 3 of 4 would just be 4. So those are the first two rules. Now let's get to the ones that are really famous around here. These are going to be seen a lot in the next coming weeks. Use it all the time. The first one is this. If I give you log base, let's say C of A plus log base C of B, what does that equal? So that's something if I give you like log base 2 of 3 plus log base 2 of 5. And what this equals, that should be an equal sign, is when you add, you're really multiplying. So this is log base C of A times B. So in this case, this would be log base 2 of 3 times 5, which is 15. So it's one of those famous rules in logarithms. Multiplication is addition. You're like, why is that? Well, remember, logs are just exponents. No way of writing exponents. So if I give you something like 3 to the 4th times 3 to the 5th, you add the powers. So when you multiply, you add 3 to the 9th. Right? And by the way, this rule works the opposite way too, right? If I give you log 2x, it's the same thing as saying log 2 plus log x. Right? And logs addition, same thing as multiplication. It's when you add two logs, you multiply the two values inside. So that's one of the first main rules of logs. Second one is the same concept, but now we're going to do division or subtraction. I'm all over the place. Log base C of A minus log base C of B. I already gave it away, so when you subtract, you divide. Right? Same concept as doing this. What if I gave you 3, 5 over 3, 4? You would subtract the powers. So same idea. So when we're subtracting, we're dividing. So log base C of A over B. Notice the thing that's negative is what goes on the denominator. It's very badly written. Let me show you an example with numbers. Log base 2 of 6 minus log base 2 of 4. That'll get you log base 2 of 6 over 4. Or log base 3/2. So, again, super important. In logs, addition is multiplication, and logs, subtraction combines to be division. Right, so division, subtraction, multiplication, addition. Okay, now let's go over one last rule. My favorite rule in logs, which is this one. Log base B of A to the K. So like your value here has a power. So it's then like log 4 to the 6th power. This rule is this. If that power to a power can move to the front. So it's going to be K log base B of A. So here, log base 10, there's nothing about here. Log of 4 to the 6th power, you can move that 6 to the front. And again, it works both ways. If I give you, let's say, 3 log base 2 of 5, you can move the 3 to a power. So it's going to be log base 2 of 5 to the 3rd, or if you want, log base 2 of 125. So those are the 5 major log rules, right? First rule is, if anytime they match, it's 1. They just cancel out, right? Because 5 to what power is 5, always 1. 7 10 matches 1. Second rule is the one we used a lot last lesson. If you have a value, if you have a number to a log with the same base, those cancel out. You just get the value or reduce. And then the big ones, when you're adding logs, you're multiplying, and when you're subtracting logs, it's the same as dividing. You can rewrite it as dividing. And then other ones, if your number here has a power, you can move it to the front or vice versa. Okay, now let's put those rules into action. So let's look at this first one here. It's a question that the book likes to ask. Given log 37 is 1.7712. So what they're saying is that, hey, you could use this. This is what we have. Approximate the value of log base 3 of 49. So we want to use this to make it manipulated to look like this. So first we go, okay, I need a 7 there. Well, 49 sending at 7 squared. So I could do this. Log base 3 of 7 squared. Now before I plug it in, because I can't, that's 7 squared, not the whole thing squared, so I can't just plug that in. I can move this to the front, use my favorite rule. This is going to be 2 log 3 7. And now I know what this is. This is 1.7712. So it's 2 times 1.7712. And voila. That's the idea. That's the idea. So let's try a couple. So same concept. Let's look at this one right here. So they want you to use log 4 base 3, log base 4 of 3, and log base 4 of 5. So the first one you're just going to wait. I know what that is. 15 is 3 times 5. So you just break it up. Well, sorry, let me write this. Log base 4 of 3 times 5. And remember, multiplication is addition. So you go log base 4 of 3 plus log base 4 of 5. You know what this is? They give it to you. 0.79. You know what this is? They give it to you. 1.16. And then you add them up. Right? Same thing here. Oh, it's division. We know what each one is. We just got to separate it so we can plug it in. So that means minus. Divide means minus. So you go log base 4 of 5 minus log base 4 of 3. Because division is minus. Now we know what this is. 1.16. We know what this is. 0.795. And you get your answer. Look at this one. Similar idea, but 3 and 4. I don't have 4 up here. Let's do it anyway, though. Divide means minus. Log base 4 of 3 minus log base 4 of 4. This, I know what that is. They gave it to me. 0.79. And this, remember the same log base 4 of 4? That's just 1. It's a rule. So you like negative 0.21. So that's the idea of how this basic intro of how to use the rules, right? If you're multiplying, it's the same as adding, so you can separate it, this plus that. If you're dividing, it's the same as multiplication, so you can separate it and subtract. And don't forget, if they're ever the same, they cancel out. So now that we know the basics of the rules, let's solve some problems. So we're going to solve log equations using this. Now keep in mind, as always, log of your answer cannot be negative or 0. X could be negative or 0, but log can't be. Like when you plug it in, it can't be negative or 0. So how are we going to do this? Step 1 is condense. That's a 1. Condense. So what do we mean by that? If you have something like this on one side, you got to make it a single log. So condense means make it a single log. So you can't use this. Can't solve it this way. You got to do this first. Right? Plus means multiplication. So condense first. Likewise, this 2 here, not condensed. You got to bring that up. So if you have something like this, can't solve it like that. You got to bring the 2 up first. So once you condense, then you can solve it like normal. Take the base of both sides. So condense, I should say condense both sides first. And then once you do that, you take the base to both sides and solve. And then 3, check your work. Make sure all the answers work. So that's the idea. So again, first step 1, that right here, hard to see. Condense both sides first. So like right here, again, the biggest mistake people make is that they take the 7 on both sides. You can't do that right now. There's a plus, there's like madness on this side. It has to be a log in each side first. So you can't do that. You gotta condense it first. So I cannot stress how important that is. Like I'm gonna highlight this. Let's see if that works. There we go. Technology at its finest. Super important. Condense first. Okay, so let's solve these problems. So again, I cannot take the sum on both sides. I got to condense first. This side, remember, plus means multiplication. So this is going to be log of 7 times 27. I'll show the work. You don't have to. Which is log base 7 of 7 times 27, 3 times 21. So 81. Should have known that already. What's an ugly 1? Over here, again, I cannot do 7. I can bring this up. So it's going to be log 7 of x squared. And now, there's only a log on each side. Now I could go and take the 7 on both sides. Right, 7 power. These would cancel. And I get x squared equals 81. Square root of that. You're going to get x equals plus and minus 9. Square root of 81 is plus minus 9. But again, if you notice, I can now have a negative when I plug it in. Like, so negative 9 is not going to work. It's only positive 9. That's my answer. And that's the general idea. Condense it first. And then take the base of both sides. Next one. Same concept. Right? So I got to, now over here it's just a 2. I can't do anything there. But this side, plus means multiplication. So log 6 x times x plus 5 equals 2. Right? Condense it first. And now I only have one log on either side. So now I could do what we always do. Take the base of both sides. That's how you get rid of logs. That's how you solve log problems. These would cancel. X times x plus 5 equals 6 squared. Now this is all the algebra. Distribute x squared. Remember, you cannot separate. It has to equal to 0 to split it. Plus 5x equals 36. Subtract 36, set equal to 0. Now you could factor it. Two things that multiply get 36, but I had to get 5. Oof, they're different signs. It's like negative 5 and 4, it looks like. Positive 9 and 4, I should say. Negative 4. So x plus 9, x minus 4 equals 0. Split it. X equals negative 9 and 4. Again, check your work. If I plug in negative 9, not going to work here. It'll be log of a negative, so that's no good. Plug in 4, works, that's fine. Plug in 4, fine. Right, so again, condense, take the base of both sides. That's how you solve a normal log problem like you always do. And then at the end, don't forget to check your work because logs are a little finicky with their domain. So a few more to make sure we really got this. Again, I gotta condense. I can't do anything there. That's the lowest it goes. But on this, I condense it. A minus means divide. So log base 4. Remember, it's the negative is the one that goes on the bottom. So 48 over n equals log base 4 of 6. You take the same base of both sides. That's how we solve a log problem. These cancel. I get 48 over n equals 6. Now the way we solve this is a little mathematics. The base is right. I want to solve for the n. A lot of people cross multiply. Too much work. Let's get rid of that n. Multiply both sides by n. As you notice, n cannot be 0 because you can't divide by 0. So I get 48 equals 6n. Divide by 6. And n equals 8. Plug it in. Works out fine. Let's not waste so much time. Let's do the next few. It's a lot more examples than I thought. Plus is multiplication, right? So let's condense again. Always got to condense first. Again, I cannot say this enough. The most common mistake I see, and it kills me, is people put a 3 on both sides. You cannot do that. I'm going to give you so little points if you do that, right? You got to condense it first. Condense. Hope that gets the point across. Right, so here, plus means multiplication, so you combine them. Log 3, 2x times 7 is 14x. Equals log 3 of 28. Look how easy this is now. You're like, oh, take a 3 to both sides. I have to get rid of a log. It's a 3 right there. You can see it. It's your fault, not mine. So those cancel out, and you get 14x equals 28. Divide by 14. X equals 2. Right? Plug it in. Log. That works fine. You can have 2 and 2, and there's 4. Right? But that's the general idea. This one right here, right? That 3. Again, you can't take the 2 both sides. There's a 3 there. You gotta move that 3 up here. So it's gonna be log base 2x cubed equals log base 2 of 8. And now, to have a log on both sides, take the 2 to both sides. So these could cancel out. X cubed equals 8. Cube root it. X equals 2. Again, you can plug it in. It does check out and it works. Man, I got a lot of these. Okay, so let's go over these really fast. So let's look at this one. This one's important because there's a couple condensing things going on here, right? So how do I condense? What goes first? Do I do this first, or do I multiply or add first? Well, this comes first because it's a power. So right, PEMDAS. So exponents come first. So you got to do that first. So that goes before this. So it'll be log 2 of n equals log 2 to the 27 to the 1/3. Remember, 1/3 is standing as cube root. I actually can simplify that because I know what that is. This is 2 to the 36. 36 got a little cut off. So 27 to the 1/3 is just 3. So this is log base 2 to the 3 plus log base 2 to the 36. Now we could do this. Plus means multiply. So again, we always got to condense it before we solve. So we got to condense this. That's going to give me log of 108. Yeah. Base of 2. Log base 2 of n. Right? That was all the hard work. Now you're just like, okay, I got them here. I could take the base of both sides. These will cancel out the logs. And I get n equals 108. If you plug it in, it works. So you're good. This one right here. Right? What's going on here? The last one of solving, after all those. Remember, we got to condense it first. First thing we do is condense. Minus means divide. So it's going to be like log base 4 of this thing over this thing equals 1. Now this is an important one because a lot of people get so caught up on how to solve these, and it's like, oh, this is easy. Just take the base 2 both sides. Same thing here. This is equally as easy. You know, there's only one log. You just take the base of both sides. Logs are always solved the same way. You condense it and then take the base of both sides. The exact same way. So I'm going to get 2y plus 2 over y minus 2 equals 4 to the first. Now we just got to solve this. This one, again, same idea. I would multiply both sides by the denominator. Don't forget over here to distribute. So you're going to get 2y plus 2 equals 4y minus 8 because we distribute that 4 to both of them. Now we just solve, subtract 2y, add 8. I get 10 equals 2y, so it's 4 minus 2y. Divide by 2, y equals 5. Check your work. If I plug it in, I get a positive, that's good. Plug it in, I get a positive, I'm all set. So that's how you solve. Again, cannot stress enough, condense first. Then you take the base of both sides and you solve it like normal. Don't forget to check your work. Okay, almost done. Let's finish this up. So look at this one. This was interesting. Solve for n. Now look at, there's a lot of variables here. There's b's for bases. There's an x there. I don't care about any of those. I just want to solve for n. Remember the way we solve for n, or you solve for any variable, is you isolate it. So let's get this thing by itself. So what I'm gonna do here is I'm gonna subtract off the 2 log base b of 16. That's what that says. Log base b of 16. There we go. It's a little bit better. Minus 2 log base b of 16. So I'm gonna get this. 6 log base b of n equals log base b of x minus 2 minus 2 log base b of 16. Now I get to here, and it's just like a normal problem. You want to get rid of the logs, so right? I want to get rid of all these ugly logs. So I take the base of both sides. I can't do it yet though. I gotta condense everything. I gotta move this 6 over here to be a power. I gotta move this 2 over here to be a power. It's gonna be 16 squared. I have no idea what that is. And then you have a minus sign, right? That means subtract, divide. It does mean to minus subtract, but in log that also means divide. right? So I got to combine these two to make it one log. So it's going to be log base b of this over that. 16 squared, I don't know what that is. And this side, move that up, I get log base b of n to the 6. So now, I did all that work. I can get rid of the logs now. Just take the base of both sides, so like this. These will cancel. I get n to the 6 equals x squared minus 2 over 16 squared. I think it's 256, that's what's in my head. And then from here, how do we solve it? Well, simple. Just take the 6th root of both sides. And then equal the 6th root of x minus 2 over 16 squared. Come on, we're an odd algebra 2 trig. That's a fine answer. And that's the idea for that one, right? Just get n by itself. So same as just practicing. Again, if you want to cancel out logs, you got to condense it. It has to only be at least a log on each side. It can't be more than one log on either side. That's probably the best way to say it. Quickly, true or false? The last thing we're doing today. Right? You want to know if this is true or false? This one is false. That's not the way that works, right? What does this mean? Plus is multiplication. This should be log base 4 of 2 times z, or 2z. That's not what this means, right? You don't just break up. You don't break up addition. You break up adding is multiplication log. So it's a little funky. So this is false. This one right here, they're saying is this thing all of this. Let's break this up ourselves. Let's go. Okay. I have this. How would I break that up? Well, multiplication is addition. So if it's something like this, plus log y cubed. Notice how you're dividing by z to the 4th. So that's being a negative minus log z4. And then you have all these powers. So you gotta do my favorite rule. Bring them to the front. If you do that, you're gonna get 2 log x plus 5, 3. I can't read my own writing. It happens all the time. 3 log y minus 4 log z, which matches. That's how you condense. That's how you expand. Break it up. So this one's true. And there we go. We're done.